Hello, everyone. My name is Lili Mou, and I'm going to introduce our recent progress on search and learning for unsupervised text generation, published AI Magazine 2022. I'm an assistant professor at the Department of Computer Science, University of Alberta. I'm also an Amy Fellow and Ken CFA Chair. So first, an ad, and I'm admitting all level students as well as visiting scholars. If you're interested in our work, please don't hesitate to contact me. Text generation has wide applications such as machine translation, summarization, and also grammatical error correction. It also has scientific questions such as nonlinear dynamics or multi-model distributions. Traditionally, text generation is accomplished by supervised methods where you have a parallel training data and you're going to learn to predict the target sequence based on the input information by cross-entropy loss. And in our recent work, we address unsupervised text generation where you only have a bunch of text and they're unlabeled. And unsupervised text generation is also important to industrial applications because in the startup company, for example, you don't have resources to get the data. And even if you're in a big company, you want to have minimal viable product at some moment. And unsupervised text generation can be applied to address the cold start problem. Here, we also have a lot of scientific questions. For example, we model it as a search problem, and it has the unique search structure than other problems. Our general framework is we're going to define a search objective in a heuristic manner to roughly measure the quality of a piece of text given some input in some task. This involves fluency of the text, the semantic coherence, and other task-specific constraints. Then we perform stochastic local search, where you have some search operations such as word insertion, deletion, or replacement. We're going to iteratively apply those operations to maximize the objective score to get a meaningful piece of text. We have successfully applied it to paraphrase generation, summarization, and text unification, where for each of the tasks, we need to design the task-specific constraint so that the search algorithm is aware of what task to solve. And we may also apply different search variants, such as simulated annealing or hill climbing, to maximize the score. Generally, results show that our search-based method works for a variety of applications, and the output is surprisingly fluent, despite the slight concern whether the search operation would corrupt the sentence. We also noticed that the search may be noisy at some moment, and also it's inefficient because we probably need hundreds of proposals and re-evaluations for each sample. Therefore, we propose to train a seek-to-seek model from the search results with different learning losses, such as cross-entropy training and max margin training, and it can further improve the performance to a very large extent. In conclusion, our recent development proposed a search-based framework and also a learning from search framework for unsupervised text generation, and we have applied it to various tasks. And I'm also going to mention that the search-based framework is not only restricted to unsupervised text generation. Even if you have the parallel data, you may use the same framework to improve the semantic coverage or to perform controlled text generation. And also our ongoing work combined the framework with prompt-based text generation, which can improve the performance to a very large extent as well. Okay, thanks for listening. And here's the ad again.